close till I get up. Time is barely on our side. I don't wanna waste what's left. The storms we chase are leading us, and love is all we'll ever try.
Now today I start the integral of by successive reduction, and the first question is, if un equals to integration of 0 to pi by 2 of x to the power n of sin x dx, then prove that un plus n times of and the successive reduction. So now un plus n times of n minus 1 of u of n minus 2, that's equals to n times of pi by 2 whole to the power n minus 1, that's it. And now from this question we can write, we have that from this question this, so integration of 0 to pi by 2 of x to the power n times of sin x dx, that's it. And also watch my previous videos also. So here also un from this question, that's it. And now it's the one is the first function and one is the second function, so I also write that integrating it's also by parts, and you also say that integral by parts, that's is same word of this. And this take the first part and this take the second part. So now we can write un equals to, as from this question, that is x to the power n, which is whole times of, and we know integration of sin x dx, that's equals to minus of cos x plus plus c as a arbitrary constant. So now I write also minus of cos x, and I can write c as is the one of the part. So now minus of n, and the second part integrating. So now n times of integration of x to the power n minus 2 of cos x, and minus becoming plus of dx, that's it. And now that's equals to minus cos x, and I hold the limit. So now 0 to pi by 2 and integrating of 0 to pi by 2. So now integrating of 0 to the power n, which is also 0, that's I write minus of 0. And now cos of pi by 2, that's equals to 0, we know it's as like your eyes and that's it, and it's very nice. And now plus of n times of integration of 0 to pi by 2 of x to the power n minus 1 times of cos x of dx, that's it. And now again from first part and second part taking, so I also write that again integrating by parts, and you can also say that integral by parts, that's the same word and same meaning also. And it's the first part and it's the second part, it's you taking from this, that's it, x to the power n minus 1 times of cos x. So now integration of cos x, we know from this question of dx, that's equals to sin x plus c as a arbitrary constant is c. And I also take from this sin x, so I put it down sin x, and the limit is set by me, that's is 0 to pi by 2 and minus of, that's so now n minus 1 times of integration of x to the power n minus 2 as from this, and that is cos x is becoming sin x and the integration function, so dx. And this n, which is also whole of n, that's it, which is also multiply of n, so that's equals to 0. And sin x of when x is pi by 2, that is 1, so now pi by 2 to the power n minus 1 times of 1 minus of 0, which is also whole times of n, and minus of n times of n minus 1 of this. So the as like this question, so I can write u of n minus 2, that's it. And from this un and the both part of LHS is un, so now un and un is becoming, so un plus n times of n minus 1 times of u of n minus 2, and that's equals to also and this n, so I write down the n, and pi by 2 whole times of n minus 1, that's the actual answer. And here I remarking by red pen and blue pen, and here I also take down this remarking. So by red pen, and I remark also the answer. You can say it's a answer. Yes, it's the required answer, and it's also proved as you consider that the first and second. You also watch part by part, and I also you watch un and plus is plus coming and n times up, that's coming, u up n minus 1, that's coming, and n times up pi by 2 up whole to the power n minus 1, that's coming also. And this the first part and second part, and is the first part and second part. And we also know from this our basic integral calculus, and watch this that videos, and also watch my previous video. Thank you, have a good day, tata. And also watch my the next video of this, and this the I take that's question number 17, that is if I of n equals to integration of 0 to 1 of x to the power n times of 10 to the power x of dx, then so that the n plus 1 of I of n plus n minus 1 times of I of n minus 2, that's equals to pi by 2 minus 1 by n, that's it. And we have the integration of 0 to 1 of x to the power n times of tan inverse x dx. And now as we have the two parts, so now integrating by parts is coming, and I take also this the first part and also this the second part, this simplify. So now that's it, x to the power n plus 1 by n plus 1, that's it. It's very interesting. And now that's times up tan inverse of x, which limit I set also 0 to 1, that's it. And now minus of integration of 0 to 1 of x to the power n plus 1 by n plus 1, that's it. And which also times of tan inverse x, that's integrating factor. So now integration of tan inverse x dx, that's it, 1 by 1 plus x square plus c as a arbitrary constant, and that's it. So 1 by 1 plus x square, sorry I cannot write it c, so I also write dx only, as it's a integrating of one part of this by parts. So now putting that x equals to 1, so now if x equals to 1, so I also write it tan inverse x, that's equals to when x equals to 1, then pi by 4 is coming, and when n equals to 0, then therefore the 0 is coming. So now is from I can write it 1 to the power n plus 1 by n plus 1 and whole times of 5 by 4, that's it. And that's minus of this part is outside of this integral factor, so I also write it minus of 1 by n plus 1 integration of x to the power n plus 1 by 1 plus x square of dx, that's it. And it's also I of n, I can write it as I red pen remarked that it's not also. In this function I take it from denominator to numerator, and it's also RHS to LHS, as this function I remarked it by my red pen, and that's it. And now n plus 1 times of I of n, that's equals to I can write pi by 4 minus of integration of x to the power n plus 1 by 1 plus x square of dx, that's it. And that's I also bracket it as a rough paper. And now here my black pen replacing, sorry it's also replacing by n, replacing n by n minus 2, that's it, as n plus 1 is coming. So now n minus 2 is, so now n plus 1 when n minus 1, n is becoming n minus 1, therefore we can write n minus 2 plus 1, that's equals to n minus 1, that's it. And now it's the rough, so now the main answer is becoming by the simplify is n minus 1 times of I of n minus 1, that's equals to pi by 4 minus of integration of, which is also integration of the limit set. I also forget that. So now limit set every there, that is 0 to 1, and therefore that x it's coming, x is coming. So now x minus 1 minus 2, that's equals to x of minus 1, that's it. And now x of minus 1, which is also coming, so the denominator is 1 plus x square of dx, that's it. That's a big idea from me, and now working for it. Yes, you can take a screenshot for it, and I also remark it first and second equation. So now is the first and is the second, that's therefore coming. And now I also write it adding, as I add the first part and second part. So now that's equals to, I can write that now adding 1 and 2, that's equals to also n plus 1 of I of n plus n minus 1 of I of n, that's equals to 5 by 4, and 5 by 4 is marking, so now 5 by 2, that's it. And that's minus of integration of 0 to 1 of this 0 to 1 also, and this coming as denominator is same. So now the denominator is coming x to the power n plus 1 minus of x to the power n minus 1 whole by of, which is denominator is 1 plus x square, which is of dx, as integrating factor is coming. So now 5 by 2, sorry pi by 2 minus of integration of 0 to 1 of x to the power n minus 1 whole of x square plus 1, that's it. And the denominator is 1 plus x square of dx, that's it. And I can it the simplify, that's. So now I also refined you that this function how to coming. So now we know also x to the power n plus 1, that is also x to the power n times of x, and where x to the power n minus 1, that's it, x to the power n times of also minus 1 is the power. So now 1 by x is coming, so x to the power n when common, so now x plus 1 by x, and that's equals to, I can write x and x square plus 1, that's it. And x to the power n is the outside, so now x and x to the x, so now x square plus 1 times of x to the power n minus 1, that's it. That cos for I becoming this part as a numerator, and that's it. And that's it is very equal, and this simplify and cutting out the numerator and denominator is x square plus 1, that's of n plus 1 of I of n plus n minus 1 of I of n, that's equals to pi by 2 minus of integration of 0 to 1 of x to the power n minus 1 times of dx, that's equals to, we have also that we know also as this part. So now we can write it integration of x of dx, that's it, x and x to the power 1, so now x to the power 1 plus 1, and denominator is 1 plus 1 of c, as a arbitrary constant is c. Hence I also write for you n equals to, also here from this n equals to 1, that's it. And now n plus 1 and n plus 1, that's coming to, so now that's equals to pi by 2 minus of, which minus is coming from this, I also write this as box. So now x to the power n times of by n, which is limit also 0 to 1, so now pi by 2 of minus of, that's it, 1 by n minus of 0 by n, that's it. And that's equals to, we also know that pi by 4 minus 1 by n, that's it. And this very simplify of this function, so that is also is the, that is find. So now this coming, the left side is n plus 1 of I of n plus n minus 1 of I of n, that's equals to also, that's it. So now the by I red pen. So now pi by 2 minus of 1 by x, sorry, it's also I write again. So a pi by 2 minus of 1 by n, and it's also answer. Thank you for the watching video. Like, comment, share and subscribe my YouTube channel, and never press the bell icon. And it's also the proved the first function of this from this question. So now thank you for watching this, and this is very same, and from this function is very important mathematics. And this part I also watch this for you, and I can write that integration of x to the power n minus 1 of dx, that's equals to, I also write x to the power n minus 1 plus 1, and the denominator is n minus 1 plus 1 plus c, that's it. From this x to the power n is coming, and by of n plus c as a arbitrary constant, that is also this question answer. So I as a wrap, I did it as a wrap and for you, and this minus of 1 by n is coming, and as like is. Thank you for watching this video. Like, comment, and also share this mathematics for your students, and like, comment, and subscribe my YouTube channel, and never space the bell icon, and also watch my previous videos as like you.
Yeah. MD, JPB, it's only right, baby.
Yeah, why you mad? I got a bag, bro. Name hot in these streets, no Tabasco. But I'm so stubbed, that's a fact, Joe. And if you think I'm frontin', you can run it back, yo. Go on, run it back.
You know that I run it. Everything you wanna do, I already done it. And I got your little boo telling me she love me. I got this one, that one. Damn, it's gonna be a long night. Yeah.